Okay, hello Dave and Anne. I've just put this quick slideshow together for you just to review where you're up to. I think we've got the 5-year period up is in November 2016, so time is ticking, but yes, we'll just go over this. So why choose Bella for your project-based management? So we look at my curriculum vitae. Bella offers over 30 years experience of a combination of allied construction disciplines, which means I'm very skilled in building and design, so which it takes when you're looking at modular construction. It might seem easy to say, but there's some you need to know a fair bit about other allied industries to complete it and do it cost effective and without any hiccups. So the average building contractor lacks the combined knowledge base required for the effective utilisation of computer numerical cutting and processing. So not, even though it's used all over the world and it's becoming more widespread, it's still not commonplace, but it's getting there. And I happen, yes, I'm quite involved in the computer generation of buildings. A brief outline of the combined practical theory and regulation compliance that forms part of Bella Stephen May's curriculum vitae. Academic professional history and achievements as follows. Okay, a sound knowledge of modular processing and construction issues across a variety of projects, including working as fault finder and problem fixer for Evolve module. So I'm skilled enough when Evolve module up on the Gold Coast at Peter Valaris that we nearly ended up with the machine there. I had to go and fix his problems just to get him up and running enough. He wasn't skilled enough to complete his modular setup, but so he employed me to model check and advise, fix issues with joining module components on site. I had to go up and fix where other builders couldn't do it. Advice on packing and handling, they were hopeless at packing and handling. Detailing and producing CNC computer numerical cutting, engineering and council approval projects. So I've been involved in that for years. Supervision of modular construction, I've been involved in that and moving houses and so forth for many years. Leading program collaboration across disciplines, I've got the state-of-the-art Revit and linked. I've been working with the Lithuanians and Space Gas, linking all these programs together to make it streamline. Successful cost-effective project engineering and completed buildings that I've put into practice and it works. So I've got some good, happy clients and some good projects that show that it does work practically. Sound knowledge of geotechnical issues across a variety of projects, working with engineers in the field and practically ways of moving, placing and founding heavy structures in difficult sites. So this is another one of my hats, is working with difficult sites over cliff faces, transporting conveyor heavy structures over swamps. I can give you stories and places and so forth that some of the jobs that I've undertaken and accomplished where nobody else possibly could have or would have. 15-metre towers in the river delta. I was contracted by the maritime services to put the lead light towers there under Clarence, 15 metres tall, in boggy country. Designed and building within coastal landslip, all the hotel and all that area is under critical hazard zone slip. I've been working with them for 6 years or something. Underpin, probably more, 20 years. underpinning homes and other structures subject to foundation subsidence. I've saved a lot of homes by rejacking them and underpinning them. House raising and moving contract for over 10 years, which I've been, that was interesting work. The principal hands-on licensed builder contract for over 25 years, working and performing deep pile foundations and timber piling, etc. So basically, not that variety, that many hats you're going to have to move and control modules. It's like shifting houses basically, but I'm very skilled in that area, so I know that it works, and it can be cost effective. Designing and detailing a variety of structures ranging from lightweight to mass density concrete bearing structures on site in locations including and not limited to the northern beaches. We've done some beautiful big place there on it's got faults on the cliff face, Broken Hill, it's got bog issues in the wet, hard to get to, severe weather conditions at Broken Hill, Central West, northwestern New South Wales, Agnes Waters. I do a fair bit of work up there, Cairns area. I've done a couple of years architecture and worked all around the area, Port Douglas, out at Gundawindi, designed structural buildings. It's also can be very tricky country, that clay country out there, the black soil country. It's also very foundation tricky. Sunshine Coast, Torres Strait Islands, done a 3-unit development for a air pilot up there on that island. And so, and then a sound knowledge of transportation issues across a variety of projects, including working with contractors and practical application of moving and lifting heavy structures in many difficult sites and situations, e.g. working with surveying cranes ranging from 12 to 200 tonne. There's some few tricks in it. It's not there's calculations and all sorts of things, so not to be taken lightly. Working with understanding field, yard, mobile, all-terrain, track and other base configuration types of lifting plant, and there's also overhead gantry plants and so forth that I've been involved in over my working life. Designing for road paths, times, heights, widths, roads, collaboration between different states, time zones, and the regulations. So it's more than meets the eye. You just don't get on the road and move a box. You've got to make it comply to everything. And I do that as a part of the design. I'm aware of that. Insurance and OHS responsibilities, which is very important also. Packing and handling is important, so you keep the quality in the product. Working with transport personnel and individual contractors. The truckies are a mob of their own, as you realise. Transporting over mass and over dimensional structures on the road. It's all a part of the laws and regulations. My informative years as son of a heavy plant operator, I grew up around dozers and plant and trucks and so forth. I'm an owner-operator of my own backhoe and maintain it and so forth. Drilling and boring rigs experience. I used to make screw piles. We've been involved in underpinning and boring and drilling, so forth, over 20 odd years. So that all helps in broadens the field, gives a much more greater base than just a normal builder that's just used to putting up frames and gyprocking and so forth. Sound knowledge of mechanical principles, issues across a variety of projects, including working with contractors in the field and understanding torques, vectors, applied loads, moments of forces and inertia. This is what most builders really don't get into. If you're a clerk of works and so forth, you get into these things. I've researching engineering and finding with heavy loads and so forth, you start to get practical experience, and then you have to work out the mathematical side, revise that and work out, okay, that can be done and that can't be, and where to watch out for safety and movement. Movement is very critical in when you start lifting modules in big fixed cubes and so forth. You've got to be aware of all these to make it possible and safe. maintaining heavy plant and equipment, which is, there's a fair bit in. Practical experience of linking different ratio gear haulage equipment. I won't go into it, but basically heavy big horsepower machinery, you can't link them together if they got different ratio gears and so forth, because one will fight against the other and you'll snap big chains and all sorts of stuff. So that experience in that. Practical experience with dog and chain, configuration types, load link, stresses, centroid positioning, which is how to lift. It's a bit of a science in itself. Designing and construction of lightweight and heavy density concrete tilt-up panels. Now tilt-up panels, I've designed and built the BWS concrete tilt-up and other structures in North Queensland. And built them, McLean, and it's dealing with heavyweight structures and cranes and lifting. It works quite well, and cost effective, mostly in industrial. Designing, modifying, building of purpose-built plant and equipment. You can see there I've built 2 machines to hand pile drive a pyramid, 6-metre pyramid at the beach at Yamba there to save a unit, which worked quite good. And sound knowledge of metal fabrication, issued across a variety of projects, including working with contractors in the field and operating and managing a engineering steel fabrication workshop, which I used to produce steel project homes, and done a range of. Shipped the furthest to Agnes Waters, done 3 or 4, got into paper for those, so that was under a factory processing system, so I knew that worked. Particular experience in personnel management in the factory process, all a part of running the factory, where the other Thrifty Link hardwares where I used to have my factory in there in Newquay Street. The practical experience of replica processing using unskilled labour. There's a little bit of a trick to that, of course, but once you teach one thing and have the process of replication in place, it doesn't take. You don't want a skilled person, they don't stick with you, they get bored. So you can bring labour costs down by 2/3 if you implement that practice properly. Piecework, budget tracking, incentive programs, teamwork, rhythm setting. So that's all personnel, HR management. I've spent a lot of years employing a lot of people, so I'm skilled in that area. Designing, modifying and building of purpose-built plant and equipment. That's I can adapt and build and design the equipment to suit the rolling process. As a full licensed builder, so you can see what all the different hats I've got that make modular possible and safe, and that's what it takes really. As a full licensed builder and licensed building designer, building designer in New South Wales, Bella offers a client a competent and proven cost-effective building management and computer numerical cutting system with some of the advantages listed below. So you got to trust your measurements taken. It just didn't happen overnight. Over time, there must be a better way. Labour costs were getting too high, so I perfected it with my building designing and design it into my buildings, because the old ad hoc way isn't cost effective anymore. You got to be up with the times and use the technology, the current technology, and let the machines do the processing basically, and assembly. We just turn, it's like the car industry. Houses have to be moulded in the same way, that it's a process. It's a process line, not a stand back and scratch your head type scenario. The practical building experience and knowledge to effectively utilise the world-leading current technology to streamline and control costs and quality outcomes. The accomplishment of uniting other disciplines in the construction and to optimise the world-leading technology into Australia. They're mostly doing it in America. Government schools, you won't be awarded the contract if you haven't got a BIM computer generation system in place. Australia's a long way behind it. One of the forerunners in Australia to adopt effectively utilise the computer and material processing ability that is currently available across other parts of the world. The ability and fortitude to be able to offer this combined and enhanced building mythology. So without all these other disciplines and hats that I wear and have been involved in and experienced in, so it puts it together, and it's not just a whim that you should make modules. I've tried and proven and grown to this point where it's really only economical. I wouldn't build any other way now. I'm aware of it. The accomplishment of working with manufacturers and computer programs to bring together the means to offer effective quality building. So I've worked with, as I say, with the Lithuanians and Space Gas to link the engineering and Metrol, the suppliers. So I put a lot of my own man hours and tracking costs and so forth to make sure that it can be accomplished. So we look at an overview of BIM and the CNC, computer numerical cutting and engineering. So in layman terms, from excuse me, from the client's brief, a 3D model is created. This is an intelligent model is more than a pretty picture. Unlike the current AutoCAD drawing, DWG drawings produced by a greater portion of Australian professional architects and building designers, which is processed and redrawn profession after profession, then given to a builder for price, interpret and build ad hoc. So now there's a lot of architects so forth using the 3D program, ArchiCAD and some of those, so they get the pretty picture, but there's very few taking it to the next level using the BIM. Some of the bigger firms with a specialist BIM operator might be using it, but then the computer generation, CNC cutting code from there is another. So structural steel shed people are using it, process. That's why industrial kit sheds and so forth are produced in that manner, but in the housing industry they haven't caught up to what's available, and that's what I mean, working with programs and so forth to turn the architectural home into be able to access this engineering and computer generation cutting. I call it the robots. Give it to the factory with the robots in it to do the work, basically, because it's cost effective. This intelligent building information handled correctly is producing high quality buildings at reduced cost. So you still got to keep your wits about you and know what to look for and double check mechanisms, but once you get that in place, it does reduce costs by a great measure, which I'll show you as we go. The average of the BIM building information, the advantages of BIM, building information modeling, as I say, it brings every cost, and it's a working cost, so which I'll go over. If you want to take your building to the next level, more time should be spent with the BIM and work out what finishes and what costs you really want to spend, and look at the budget and then work your building to your budget. So, because there's no use building something that's not going to work financially, and that's one of the main important things, working financially. The cost planner is undertaken and interactive in real-time modelling process. So the beauty of Revit and the modelling, the structural, it's got architectural and structural that links to the engineering, so which is also linked to this cost, this BIM. So it's interactive. So I mean, really, it's that whole process that the current technology offers, and put in with applied with practical experience into the building process, yes, you can achieve good cost-cutting mechanisms, because it's information that's the key here, and being able to control what you do before you start building. The client is in control of rail costs at the planning stage. The collaboration with other disciplines and the accuracy and combined real-time information is shared electronically, greatly reducing the redrafting requirements. So at current, not one profession handles the plans. The architect will do the architecture, then it goes to the engineer and the quantity surveyor, and then to the builder. So you're getting this four areas where profit has to be individually extracted from each transaction. You've got a redrafting, so you got 4 different drafting people drawing the same thing. So that, just in that side of it, there's cost savings to streamline it, get it all off one model, get it right the first time. And the interactive model and the new technology has the capability, so why not use it? The process of manufacturing the structural content from this model, sending it to a robot manufacturer, if you like, producing fixed cost, quality, accuracy, and this time saving. So to computer generate it, the machine punches it, so you actually buy it for the same cost, but it's manufactured. It can be formed into any shape and architectural building, and you're getting it for the same price as uncut lumber, linear length of lumber, or steel. So you add this process from this model, and you can generate the robot is hardly touched by man. It's pumped out of a rolling mill and produced and cut, and so really it's just a practical application, really, that computers allow. So this computer-generated process of building components can be put together by unskilled or cost-effective labour. So yes, once you get going, as I say, you don't want overskilled people, and you train the person, an unskilled person you can train to do that particular one thing and do it well and do it fast. Where you pay a tradie, he's got his own mind about it and he actually stuffs it up. He's more likely to stuff it up. So the quality and cost is fixed when the model at planning. So yes, it takes a bit of, you got to concentrate, work closer with the client, and address it before, because you're going to have to address it at some stage. You just know it's better to be done on paper than it is in the physical down the track. Reduces headaches and stress and everything. So, and that's another reason that my experience has brung me to working this way, forward, not backwards, basically, to reduce stress, and is another big part. Complex and enhanced architecture features are computer generated, simplifying the building process and controlling costs. So the more you trust your measurements, the more accurate you get it. The more the machine works to exact measurements, the higher quality you get, because it's neat as a pin, it's accurate. And you can control costs, because you know every bit and what's involved. There's no, we didn't allow for this, or we didn't see that coming, or because this goes against that, we have to chop this out of there, and that sort of stuff. This ad hoc stuff is just, you can't, normal people, or the business economics really doesn't allow for it anymore. Can be further processed into larger modules, components for difficult access sites to further reduce on-cost and site management issues. Okay, so if it works to put it together, to cost effectively to put the generated pieces together, it can also be very cost effective to put it into larger components, e.g. modules. to for difficult sites, which the high street site is very difficult. So that's a big saving in itself. This process also allows overlapping of trades, not possible conventional. Yes, so on that tight site, and you got 20 tradies running over the top of each other, the quality is reduced, there's more stress, and you just physically can't do what you could achieve working off-site, bringing the modules, getting them all made. 12 modules in your case can be built off-site, ready to move in, so you can save 12 weeks of work, and on site in 4 days your project comes together without that overlap of stress and inefficiency of trades and organising the site logistics and so forth. So that's another big plus for module. Summary of module component methods. Quality control, because it's computer generated, it's needed. You model it and it comes out identical. If not, it's the robot has to be re-oiled and rejigged, you know. So there's controls, quality controls on that side of it, but that's the manufacturers issue, not the builder or the contractors. Cost control. Yes, because you know you've got the BIM, you control the cost. Allow more trades to be, and it's engineered, so you're engineered to finite mechanisms, so you don't there's not unforeseen blownouts. Allows more trades to be working at the same time, as I said before, at different locations, the right cost-effective choice for difficult sites. That's why modular comes into play. More for your money, so that's the cost-effective and better quality, quantity. Reduce higher-end labour costs. It has been worked out and processed, so you don't need a lot of skilled people rethinking a job. One person draws it, and then you're paying another person to work it out. It's madness, you know. You don't, once you work it out once, it's the start of the process line, and that's another why it's cost effective, because you got not only 3 or 4 professionals working it out. No, the machines work it out. It's between the client, the cost, the finishes, and the original drawing, where it should be worked out once, get it right, you know. So material production costs included minimum or no cost. Material production costs. Okay, yeah. So a stick of they can punch holes in it, cut it to the right length, exactly to the right length. For no additional cost. They're selling the material, so they may as well, and that's what they do. They add all that, the mechanic, all the numerical measurements and working out. So straight away you've saved a highly skilled person that's going to put it together. You've already got that in your model, so you're utilising that. So that's another important factor. The intelligence of the project is a one-off, as I say. Do it once, do it right. Engineering forms part of the computer generation process, so it's linked to an engineer to space gas to engineering programs. So that's streamlines the process remarkably off the one drawing. It happens within the same realm, not taken out and redrafted and worked out and physically calculated out and so forth. The modelling process, the modelling generation engine of the space gas engineering programs are intense. They do millions of calculations and run process. So just that process in itself, which pumps out a CNC file, as engineered CNC file, is a major saving. So the basic principles of how BIM and CNC is achieved. So how do we achieve it? So that's a computer generated model of the 3D realistic with its length, price, nuts fixings. So it's done the builder's work. That's what a builder does on site, measures and cuts and so forth. So the plans, the model's already done that. So straight away then you say, okay, this little place out at Asherby, with BIM, he just wanted a simple box, a rectangular box for using BIM. It was evident that it was cheaper to fill in, use the structural framing underneath and gain a extra laundry and battery room and so forth, instead of just poles and big cross bracings and so forth. So for $126 different, it was better to go this way, and that's the other advantage of BIM. You can manipulate it or mold it to to your budget and get the best quality out of it. See, that's why it's important, and not it's it's using the technology and being able to use the technology today to produce, to get to this level, to say, well, wow, that's what you want. Because otherwise, if you mechanically work that out, physically work that out and try and cost the cost of quantity surveying and changing it, you would never do it. But at the click of a button, when access to information is readily available, you can do these quick calculations and come up with the optimized building for quality and cost. So that's I can't implement or get enough across to people. That's what I offer. So this 250 square metre 3-bedroom home, 2-car, 2-bathroom is quite nice. It's been computer generated with solar aspect. Picked up the views of the Broadwater while shading all the areas and allowing winter sun, and all that sort of stuff. So I mean, it's just more than what it seems as well. So the BIM technology, the Revit, the three-dimensional modelling, allows thermal, solar passive aspects and studies, structural engineering takeoffs, costing, properties, building properties. So there's a lot you get in one model, and really once you're aware of it, you'd be mad to do it any other way, because the technology's there. So we look at a 250 square metre home, 3-bedroom, upper loft, nice big bedroom with a bathroom in it, all service layer clearing. So we're looking at, he's done a lot of the work himself, and he's up to that level with 180,000. That's with stainless steel water tanks and septic systems. I done this rockery with the backhoe when we levelled it out and stepped it into the side of the hill. But he'll get out of that for under 200, no worries. 200,000, which is the 720 a square metre, which in today's market, that's bloody good, really. You minimum $1,200 a square metre just for a project home. So this is a one-off on a difficult site. Lock-up finish 144. So that just gives you a bit of an idea. The water tanks and water pumps and sewer systems always add to the unforeseen, and the land clearing and so forth. So then the raw material costs. So it's quite surprising. All the cladding, the doors and windows, not the solar system, the gyprock, the insulation, only come to 53,000 for this whole house. So it's surprising, and that's the other thing. Information, once you start looking at information, then you can start looking at different claddings and optimize is really what it allows. This information gained at this early stage allows you to optimize it, and that's what I offer, working with the client to optimize their building before you start, not halfway through. Okay, so then this is another place at Kyogle. We just, it was structural, it's a beauty, went together easy. So we just have a look at just the framing content of that. So if we go Bunnings Hardware, cheapest you'll probably buy pine. We look at it's $4.90 for treated pine, because steel, the white ants don't eat steel. So we take just 1 metre of a stick, uncut. So, and then waste. See, the 5%, I didn't actually add 5% waste, so there's another 5% waste on top of that. So you're getting up to, $8.30 a lineal metre. So, and once again, so just for 1 lineal metre of uncut, so it's got no form. It's just a stick of timber, where the processed engineered metal is not only it's engineered, it's intelligent. It's a component out of a large jigsaw, if you like, where the uncut lumber's not. So you're paying a lot more. You're paying $8. So architectural design, engineering, surveying. So you look at up to 7% added cost. Where if you extract all this information from the model, you can bring that down to just do it once. So you can nearly save half your cost in admin, and come up with a finer, more quality product just in that administration area to begin with. So then, so let's imagine you just go to the hardware and buy a length of timber, and you say, okay, well then after you work it out, yes, the builder still has to process it, and somebody's got to cut it and nail it and measure it to length. So, and then the builder has to put a big profit on that, because he's running teams and tools and so forth to cut and measure it and get rid of the waste and God knows what. So I mean, realistically, that's still, that 1 stick of timber that you look at in the hardware store is going to cost you $8.24 the time it gets into any form in your building. So then we look at the computer generated building method that I offer, and we're going to approximate 38% saving just in the framing content. That will be less because there's other areas where you can't use computer generated, but just in this part of the process. See, and also what happens is when you get everything neat, everything self-squares, it comes into shape, as long as you start off foundations the right heights and so forth, but there's a quality control check there. And once it starts going together, it becomes easier and easier to come together, because it's quality, it's perfection that brings it together. So then when you're doing lining and fitting your doors and windows, everything goes a bit smoother and smoother and smoother. So really, that's the other secret. That's the quality secret and the labour saver. You're not chasing your tail, or so it's already worked out in front of you, just fitting it together. So, and all the processes are done in one. The admin processes, as I said before. So you're only adding 5% to detail it, engineer it, but you're already done in the beginning. Labour processes, so 20%, you still got to put the frames together, somebody's still got to do it all, so, but that's reduced. So, and project administration, so if you're doing it under the project administration basis, you don't have to, because you're not running other skill labour and so forth, you can still, you can reduce your profit on an admin basis, rather than a builder's margin. And that's another big saving. So that's starting to look, the $6.36. So you say, oh, it's only a couple of dollars a lineal metre, but that's half the cost of the original material cost, and you go 2,500 lineal metres or something, it does make a difference. Okay, so you got this is a place nicely finished on the inside, quite I think 270,000. We turned this old grey box into a mansion, so saving them 6,000. So no scaffolding, just on itself was a great cost saver here, and time. You didn't have to, once the top was on it was finished on the ground. But from the top down to there was finished in one mechanism. It's great, and you're just working off hardly have to work off a step ladder to finish it when it's on the ground, instead of bloody 6 meters in the air. So So that's dramatically reduces costs with quality increase at the ground level. So it's easier if you're working on ground, not up on planks. Your concentration, your quality, your speed, everything is better. Okay, that's just a bit of an indication occur there. Okay, so this is BIM modelling, allows cost control. So what happens is you can cost by knowledge, by information, being aware of it. You can say, well, here, these tiles, if I use an Italian tile here that's $100 a square metre just for the tiles, how does that affect me budget and the different fittings? So if you know all this, then you start to say, okay, well, no, that's going to blow budget, but there's not an Italian pattern, but there's a similar stone tile that's produced in Indonesia that's seems just as good as quality, and the finish is the same, so the outcome's going to be the same, but your the bottom line, your budget fits in, so the whole project becomes economically viable with no loss in quality. That's why this BIM is so important. You got it, they're the decisions. That's good planning, basically. So, and the programming allows you to accomplish this. What costs a stone? So it gives you this. Yes, you have to do more work, but as I say, at some stage you're faced with that same issue anyway. So they're the townhouses, the fence, so you can even do it down to simple fence, bill of quantities, just the different styles. Okay, and this is the modular setup for the townhouses. The 4 modules complete the whole building. Simplified, there's clearances and stuff, and when you start to work with it, it's just not as simple as is drawn on the plans, as experience and so forth, connecting and lifting and areas and so forth. So, but as far as the end outcome, once they're joined together, it's no different than building it in any other way. Better, because it's neater. It has to be precise and exact to work. So you actually end up with a better building than an ad hoc building. So, and they're designed to fit on the trailers and so forth. So that's cost effective. That's just a bit of pre-experience, knowing that you have to work that out to work. Here's the units. I mean, they're quite good. Who offers 3 car parks, toilet, laundry downstairs. So you've got that that comfort in these 3 bedders. You've got living areas overlooking the river. They're quite a good unit. They're still adequate sized bedrooms and plenty of cupboard space. And then depends on the finishes. So you look at the kitchens with BIM, then once again we'd sit down and refine this, bring this right up to speed, so you know what your PC items, what you want to spend, what your budget is, and what level of finishes you want to achieve in relation to your budget. That's what's important, very important. Otherwise you'll blow budget, and it creates a higher market price. They don't sell as fast. You can't rent. It's just a place you don't want to go. You've got to get it right at the planning stages. Okay, so we look at a simplified cost breakdown of just 228 units. I've just averaged them out. There's 600 square meters, not including the garages, but I've added the garages into the site works, so because it's a part of the foundation work. So we look at admin, 93, so 154, 300 for the site works, which we can 100,000 per garage unit, but we can look at that. We can also refine better mechanisms to obtain the same engineering outcome there. So there is some other areas, but I'll go into later. Unit costs 440. At 729, so we're not much different from the other house supplied. So that's a good indication that things are correct. So we're at 129, 130 for the actual building, which is 166 per townhouse, is quite good still. 440 but it's still unit cost 440. Oh, that's for the 3 units. Okay, so PC items 50,000. Now that's probably not enough. You could spend over 3 units 16,000 each. You could possibly spend the kitchen 6. So you can go higher, which just adds to the bottom line, but that's basically what you got on PCs. So you pick toilets and tap fittings and all that sort of stuff, and start to look at in mini budgets to say, okay, I'm fitting in there, and that your budgets, if you get a higher quality finish, well, it's chosen and it's justifiable, and that it's coming. So that's what happens there. So then time you plus GST, okay, 1,400 a square metre. Okay, for building costs with those double garages and that foundation, 1,400 is actually almost seems to not enough money to build that type of construction with those foundations. So you say, okay, the finishes, the floor coverings and so forth mightn't be of high enough quality, but you still look at I think that adds up to the 850 odd thousand for the total project. But you find you want to manipulate costs, and that allows you to start to say, well, that's why it's costing me that, because I'm using Italian tiles and high-end fittings and so forth. So but this base cost remains the same. So then we just do a quick double check from the above. We add the admin, the site works divided by 3, and the construction costs and the PC items. So we come to $1,000 per square metre per unit. That's where including the garages and the site works and the admin. So we say, yes, that's too fine for that type of construction. It's going to cost more than 1,000 per square metre per townhouse. Or have we achieved it by looking at the prices and saying, okay, we know we've built that other house for that type of money and so forth. So that could reflect some of the savings. If you add 30% to that, well, there's your higher quality for the better price. So you say, okay, your reduced price is reflecting higher quality. This is Washington and Brown, Brisbane-based quantity surveyor. They got calculators online, so on their national current standards. So put in townhouses of 228 squares. On the upper finishes, there's 440 per townhouse finish, so they're up around the 1,700 per townhouse so you can spend up there. That's 1.2 million. So according to them, if you spent 1.2 million, you're going to get the upper edge. But and this is what I offer, I can say, well, if you know the cost and where you cost and putting it into the quality and keep the structure and be aware of where you're spending the money, not in builders' profits and wasted material and so forth. So you can gain, say, 30%, 38%, so 20% even off that is a fair bit. So I mean, and if you can turn that 20% into quality, so here we go. Yeah, so that's the upper limit. This is the lower finishes, which 230, that's where we're at. We're about the $1,000 a square metre. They're saying lower finishes. So what I'm saying is we're probably gaining higher finishes or a medium finish at the lower standard national rate by using this process. And and the medium finish was $1,200 a square. So then you say, okay, well, you spent $1,200 a square to say 900,000. Well, and you use this system to its optimize your quality. Then you can say, okay, I'll spend 900 and bring it up the finishes that are involved in this this 1.2 million. So that's what you got to do, and that's what this is what I offer, to work with the client to produce a higher level of finish in this computer generated model at the onset. Okay, so that just goes into some other articles. I mean, more and more people could probably have the single biggest impact on construction's efficiency, and it has to go this way. That's what I said earlier throughout the document. It has to go this way, and it will, because the whole ad hoc is just unaffordable. And you got to have 6 reasons modular construction make sense, and so I mean, they're pushing it not only in modular, but I'm not just saying modular, I'm linking years of experience, quantity surveying, BIM, client management, computer generation, to make modules a part of that system. I'm not just concentrating on module. So, but the modules are a good end product for difficult sites at the end of the line. So that's something to think over. Thank you.